Okay, this is exercise 8.5, partial sum of an arithmetic series. The sum of the first n terms of an arithmetic series, or the nth partial sum, is given by one of these two following formulas. So the sum of the first n terms is n over 2a, which is the first term, plus l, which is the last term. So if you know the first and the last term of a series and how many terms there are, this formula here, S sub n equals n over 2a plus l, will give you the sum of those n terms in the series. Now, if you do not know what the last term of a series is, you would use this formula. Sum equals S sub n is n on 2 bracket 2a plus n minus 1d. And we use this second formula when the last term, L, or the nth term, L, when we don't know the nth term or what the last term is. Okay, so we'll just have a quick look at where this is on the formula sheet. So again, on the first page of the formula sheet here, it's over here. We can see that we've got the nth term, which is what I did in the last video, sum to n terms here of an arithmetic series. So these are both arithmetic series first. Here we've got if you know the first term and the common difference and how many terms that you've got, and you'd use this second formula if you know the first and the last term. So there's no need to commit those to memory. You can always check them on your formula sheet. We're going to look at the proof for the first formula, Sn equals n on 2a plus l. So sum of n terms, if the first term is a and the common difference is d, so first term would be a, second term is a plus d, third term is a plus 2d, and the last term is going to be l. Now I'm going to call that equation 1. Now I'm actually going to do this same sum, but instead of going from a to l, I'm going to say, well, my first term is l, it's going to be in reverse. So therefore the next term would be l minus the common difference. Like, let's say this was, let's just say, for example, our first term was 2, then 4, then 6, then 8, then 10, up to 12 or something. So let's say this first formula is like doing it like this. And then what I'm saying with the second formula, it's going to be 12 plus 10 plus 8 plus 6 plus 4 plus 2. So I'm actually going to write this same one, but in reverse. So here d is 2. Okay, goes up by 2, and in this other one, same series, but just starting with the last term and going down to the first term. If this is the last term, then the last term minus the common difference up here. We can see that d here is 2. We know here, for example, a is 12, d would be minus 2, but if I represent this as being the same as that, using the d from here to be the d from there, I've got L, my last term. To get this, it's the last term minus d, minus 2, to give you 10. So then the next one would be L minus 2d, and this would go all the way down up to the first term. Now, look, you won't probably ever have to do this again. This is just to do the proof of Sn equals n on 2a plus l. Now, if I do equation 1 plus equation 2, I get 2 lots of Sn are equal to, now I can see here that I've got, now, if I add the first two terms, so I add Sn and Sn, I get 2Sn. A plus L gives me A plus L. If I add A plus D plus L minus D, the plus D minus D cancel, and I get an A plus L again. Same with these next two terms, A plus 2D plus L minus 2D. The plus 2D and the minus 2D cancel, and I've got A plus L plus, again at the end, sorry, I just need to get rid of this, plus another A plus L. Get rid of that too. Okay, so therefore Sn will equal n lots of A, sorry, 2Sn is equal to n lots of A plus L. Therefore Sn equals n on 2A plus L. Okay, just finished. Now we're going to do the proof of Sn equals n on 2a plus n minus 1d. Now, since L is our nth term, and the nth term, formula for nth term is a plus n minus 1d, we're going to start with Sn equals n on 2a plus L. I'm going to replace the L with a plus n minus 1d, so it's n on 2, a plus a bracket, sorry, a plus, that's that a, plus, now the L is another a plus n minus 1d. And so therefore Sn equals n on 2a plus n minus 1d. So that is the formula That's the proof of that alternative formula that you can use if you do not know what the last term is. So if you just know A and D, you use this formula, and if you know the first term and the last term, you use that other formula there. So we'll just look at some examples. Examples, simple. Find the sum of 25 terms of this series. We can see it's an arithmetic series with A is 5. D common difference is T2 minus T1, which is -4 minus 5, which is -9. Or we could have done -13, take away -4 is -13 plus 4, which is -9. So we want the sum of the first 25 terms. So let's just write the formula. Sn. Now we don't know the last term, so we just know the first term and the common difference. So Sn equals n on 2. 2a plus n minus 1 d. So we're going to substitute n is 25, so sum of the first 25 terms is 25 over 2. 2 times a is 2 times 5 plus 25 minus 1 times the common difference, which is -9. So just evaluating that on your calculator, 2,575 is the sum of the first 25 terms of that series. Okay, now the second question. It says evaluate the following: 79 plus 81 plus 83 plus 229. Look, we know what the first term is. It's 79. And we know what the last term is. It's 229. But the problem, and we also know what the common difference is. It's 2 because it's going up by 2. However, we do not know how many terms of the series we have. So we're going to have to work out which term of the series this one is. So we use Tn equals a plus n minus 1d from the last exercise, okay? By looking at this, we can't work out which term it is unless you want to sit there and guess, but that would take you forever. So we're looking at this last term. We just want to work out what n is for this particular term. So 229 equals a, which is 79, plus n minus 1 times the common difference is 2. So we've got 79 plus 2n minus 2 equals 229. And 79 minus 2, that's 77, taking that over and solving. So 77, 229 minus 77 is 152. So n is 152 divided by 2, which is 76. So therefore, this is the 76th term. So therefore, Sn equals n on 2, a plus l. Now that we know what n is, how many terms in the series there are, so we go, it's 76 over 2, a is 79, and l is 229. This question is 11,704 when you evaluate that. Third example, evaluate the sum of the series from r equals 3 to 20, where the general term is 4 minus 6r. So let's look at our first term. A would be where we're substituting r is 3. So we get 4 minus 6 times 3. That's 4 minus 18, which is -14. Now let's look at our last term. So our last term, L, is where we substitute r is 20, and we get 4 minus 6 times 20. Now that's 4 minus 120 is -116. Now we need to see how many terms there are. Remember, we do 20 take away 3, but then we have to add 1 to count both terms. So 20 take away 3 is 17 plus 1 is 18 terms. So therefore the sum of n terms is n on 2, a plus l, which is 18 on 2, -14 plus -116. That's 9 times -130, which is, evaluate that, we get -1,170. So there were 18 terms, and we needed to find that as well as the first and the last term by substituting to be able to use this particular formula here. I mean, if you wanted, you could have worked out the first term. Looks like the common difference here is -6. So if you worked out the first term and the second term and did term 1 minus term 2, you could have got the common difference. But I think it's much easier here to work out the first term, the last term, and how many terms there are in. Example, how many terms of this series, 80 plus 73 plus 66, give a sum of 495? We have the first term is 80, And we can see that the series is going down, so the common difference will be negative. It'll be 73 minus 80, which is negative 7, because it's going down by 7. We don't know what how many terms there are. We don't know what the last term is, but we know that the sum of n terms is 95. So the formula that we can use is Sn equals n on 2, 2a plus n minus 1 times d. We cannot use n on 2a plus l because we don't know the last term. So the sum of n terms is 495 equals n on 2. 2 times a is 2 times 80 plus n minus 1 times negative 7. Now I'm going to expand that. Actually, I'm going to multiply by 2. So I'm going to get 495 times 2 equals n bracket. Now expanding, I get 160. And expanding here, I get minus 7n, and negative 7 times negative 1 is plus 7. So 495 times 2 is 990 equals n. I'm going to expand actually. So we get 160 plus 7 is 167. So it's 167n minus 7n squared. So it looks like we formed a quadratic equation here. So taking this all over to the left to make the n squared term positive, we've got 7n squared minus 167n plus 990 equals 0. And we're going to use the quadratic formula. So n is negative b, which is 167, plus or minus the square root of negative 167 squared, which will be the same as 167 squared, minus 4 times 7 times 990 over 2 times a, which is 2 times 7. So that's 167 plus or minus the square root of, need to work out that expression under the square root sign. Expression ends up being 169, so it's 167 plus or minus the square root of 169, which is 13. So 167 plus or minus 13 on 4. So your two solutions are 167 plus 13, which is 180 on 14, or 167 minus 13, which is 154 on 14. So those two possible solutions are, I'm just working them out, 12.857 or n is 11, but n must be a whole number. You can't have the 12.857th term. So therefore n is 11. So therefore, how many terms are there in the series? Therefore, there are 11 terms in that series. This example, it says the sum of 12 terms of an arithmetic series is 186. So that is an Sn. So S of 12 terms is 186. That's the information we have. And the other information is that the 20th term is 83. That's not an Sn, that's a Tn. And it's the 20th term, so term 20 is 83. And you have to find the sum of the first 40 terms. Now you're given two pieces of information and you can form two equations from that. So sum of n terms, remember, is n on 2, 2a plus n minus 1d. And we know the sum of the first 12 terms, so we're going to do the sum of the first 12 terms here. That's 186 equals 12 on 2, 2a. I don't know what the first term is, but we know that there's 12 terms, so it would be 12 minus 1, which is 11, times the common difference d. So that is 186 equals 6 times 2a plus 11d. And I can divide here by 6, and I get 31 equals 2a plus 11d, and that's my equation 1. Now, looking at this other bit of information that the 20th term is 83, we know that Tn equals a plus n minus 1d. Now, we do have two options here for the Sn. It's n on 2, a plus l. But because we know the Tn formula doesn't have an l, it's just Tn equals a plus n minus 1d, it's best to use the formula with the a and d here so that you've got, we're going to form two equations with a and d and therefore can solve simultaneously. Now we know that the 20th term is 83, so 83 is the term when n is 20, so we get a plus, now 20 minus 1 is 19d, and that's my second equation. So we're going to solve simultaneously. So I'm going to go equation 2 times 2 to get 166 equals 2a plus 38d. I'm going to call that equation 2a. So now I'm going to solve simultaneously. So I'm going to do, let's try and do the bigger numbers minus the smaller ones. Let's do equation 2a minus equation 1. And that would be 166 minus 31. That would give us 135. So 135 equals, now 2a minus 2a is 0. 38d minus 11d is 29d. Therefore, d is 135 divided by 29. Whole number there, so I've obviously made a mistake, and I found the mistake. 38 minus 11 is 27. So always go back and check if you're not getting, we are expecting a whole number answer for D. So trying now, 135 divided by 27 is, and I'm getting 5. That's better. So D is 5. And so now we can work out what A is. So sub D equals 5. We'll go into equation 1. And we get that 31 equals 2a plus 11 times 5. And so 11 times, looks like a is going to be a negative number. So we're getting that 2a is 31 minus 55. And that's giving us 31 take away 55 is negative 24. And so therefore a must be negative 12. So therefore we want the sum of the first 40 terms. So therefore Sn, the formula is n on 2, 2a plus n minus 1, 2a plus n minus 1d, putting square brackets there. So therefore Sn is n on 2. Now 2a is negative 24 plus n minus 1 times 5. Because D is 5. So therefore, the sum of, I think it was 40 terms, the sum of 40 terms is 40 on 2, negative 25 plus, that's a 40 now, plus 39 times 5, which is, whatever this works out to be, calculating that on your calculator, you get 3,420. So when you get this type of question, you have to be really, really careful. So you'll be doing some of these in the exercise, and just be careful. For example, here they're telling you what the 8th term is and the 13th term. So you need to think, is that Sn or Tn? Same here. They've got the sum of the first 5 terms, but then this one's a bit tricky because it says then the sum of the next 5 terms is 160. So we're just going to actually talk about this a little bit. So you'd use Sn for the first one. Sum of the first 5 terms is 35. But if the sum of the next 5 terms is 160, they're actually giving you the sum of the first 10 terms in total. So the sum of the first 10 terms therefore will be 35 plus 160, which is 195. So when you do that question, just be careful with that, okay? And we might just pick one more question here to do, okay? So this last example, this is from your textbook, just one of the questions towards the end. It says the 20th term of an arithmetic series is 131. So S20 is 131. And we know that the sum from the 6th term to the 10th term, inclusive, is 235. So that information is the sum from, I'll just go, R is 6 to 10 of whatever the general form of the function is, whatever that's going to be. That sum is 235. Now I'm leaving that blank because I can work out what that general term, I meant to say general term of that function is. So we know that the 20th term is 131, so therefore we know that Tn sorry, no, that's not Sn, it's Tn, sorry, the 20th term. So T20 is 121. We know that Tn equals a plus n minus 1d. So T20, which happens to be 131, so when n is 20, the term is 131 equals a plus, now n is 20, 20 minus 1 times d. So 131 equals a plus 19d. The sum of the 6th to the 10th terms inclusive is 235. Now, what I'm going to do here, actually, I'm just going to leave that for now, but I'm going to do the sum of the first, of the 6th to the 10th terms will be the same as the sum of the first 10 terms, will be S10, sum of the first 10 terms, minus the sum of the first 5 terms. So sum of the 6th to the 10th terms is the sum of the first 10 terms minus the sum of the first 5 terms. So that's sum of first 10 minus sum of first 5. Now the sum of the first 10 terms, I'm just going to come up with expressions for those. So S10 equals 10 on 2, 2a plus n minus 1, which is 9d. Now this is using Sn equals n on 2, 2a plus n minus 1d. Okay, so using that. So sum of first 10 terms is 10 on 2, 2a plus 10 minus 1, which is 9d, which is 5 bracket 2a plus 9d, which is 10a plus 45d. Now that's the sum of the first 10 terms. Now the sum of the first 5 terms will be 5 over 2, 2a plus 5 minus 1, which is 4d. And just multiplying through, we'll get 5a, because the 2's cancel here, and we'll get plus 10d. So that's the sum of the first 5 terms. Now we know that the sum of the 6th to the 10th terms inclusive is 235. So that up here equals 235. So therefore, S10 minus S5 equals 235. So S10 is this equation here. It's 10a plus 45d minus all of S5, which is 5a plus 10d. So that minus that equals 235. So 10a minus 5a, that's 5a, 45d minus 10d plus 35d equals 235. Now, we need to solve simultaneously. We were told that the 20th term was 131, so that's my first equation. 131 equals a plus 19d. And this is going to be my second equation, but I can actually divide all these by 5, and I get a plus 7d equals now 235 divided by 5, I think, is 57. Just checking that. Oh, 47, sorry, it's 47. So that's going to be my second equation. Okay, so here are my two simultaneous equations. I'm going to write equation 1 underneath this one as well. So a plus 19d equals 131, rewriting equation 1. So now to work out what a and d are, I'm going to do equation 1 minus 2, because that will lead to no negatives. And I get 12d equals now 131, take away 47 is 84, and so therefore d is 7. And substituting into equation 1, we get a plus 7 times 7 is 47, so a is 47 minus 49, which is negative 2. So therefore we've worked out what d is. So a is negative 2, d is 7. So now we can work out, the question is to find, that's the question, find the sum of the first 20 terms. Now we can do that, okay? We actually know what the last term is anyway, so we can use Sn equals n on 2a plus l if we want, because we know that the last term is, it told us the 20th term is 131, so we can use that. Sum of first 20 terms is 20 over 2, a is negative 2, and l is 131. But you can use Sn equals n on 2a plus n minus 1d, you will get the same answer. So this is going to be 10 times 129, which is 1,290. And that's the end of the examples for this exercise.